And I'm going to okay, can everybody see my RStudio? Okay.
Yes.
Okay.
Yeah.
All right. So I'm already in the session in the Lab 6 folder. I don't know if we've done, it's been a while since we've done a git pull, so I wanted to remind everybody how to do this because I updated some of the later lab files. There was an issue with a lot of these file names having this parentheses 1, and it makes a lot of the things not run correctly. So I think I've updated all of them where that's not an issue. And in order to get that, you need to do a git pull, which is just a matter of going up here to the menu that says git and going to pull and clicking pull. And it will, in my case, I'm already up to date, so it didn't do anything. But it should take just a few seconds, and it should get all of those up to date for you. So if you want to follow along and you want to use the script just to save a little time, ideally you're going to want to type things out when you're practicing, but we want to get through this fairly quickly. So you may want to use the script, and that's not the script we want. Okay, so it's going to be under Lab 6. And it's going to be this script, the Lab 6R. So the first thing you're going to want to do is down here after where you source the file, you're going to want to change the set working directory. And the easiest way to do that, you come over here and you to the files, you go to more, you hit set as working directory, and you copy it and actually put it in your script. And it's important to do that even if you've already set the working directory, because when you run the script and it has this line, the RM list equals, that clears everything out, it will actually clear your working directory. So you have to have your working directory in there somewhere after that command. Otherwise you're going to get errors. So, and you highlight everything to run it. So today we're working with some tables and with crosstabs, chi-square hypothesis testing. So we're actually getting into the good stuff where you can start to do some science. The first thing that we've got to do is load the data set, and I actually jumped the gun. I'm going to change this. You don't have to do this. I'm just changing this on mine because I want to clear everything out. Okay, so the first point is we're going to load the data set, and we're loading it from a website. So that's why the source, and then you see the website name. So anytime that you have, this is actually R data, so it's in R format, so you don't have to do a lot with it. But this is the command that you'll use if you know of a data set somewhere out there that's in the R format that you want to download from a website. Once you have it downloaded, you're probably going to want to save it to your disk, as opposed to just going back to the website every time, because you never know when you won't have internet access. Okay, all right, so the next thing that we're going to do is look at a table. And the first line here, this attach, is optional. When you're writing your own scripts, it's actually recommended not to do this usually. You just have to be careful with it, because if you get two files that have the same variable names, you won't know which one you're working with if you've attached one. So the best practice most of the time is to call specific things by data frame name. But we're only working with one data frame, so we're okay this time. So this command just creates a table that shows us, I'm going to go ahead and pull up the data. It brings up the distribution for this variable, the variable smoke 100. And you can see the variable is zeros and ones. So it brings up the distribution just numerically. So there were 10,559 zeros, 9,441 ones. The next line is going to create a table with the smoke 100 variable broken down by gender. So it shows the numbers of, and so 0 is a non-smoker and 1 is a smoker. And it's just broken down by male and female. And you can do this with any data frame. So one of the first things you can do when you start looking at some data, of course, we already know you can do summary for variables. You can do names in order to get the names of all the variables. If you want to just start off, cross, looking at the comparing two variables against each other, this is one of the ways you can do it. Now we're going to create a new table that's going to be in memory. So that command created a new object out here called my table. So now we can work with that. And instead of having to type in table smoke 100 general health, all we have to do now is type in my table. And it gives a breakdown by non-smokers and smokers of health in the categories excellent, very good, good, fair, and poor. Now the next command is going to create a table where it's by proportions or percentages instead of just by flat numbers. So in this case, it's going to take the proportions for the my table object that we already created, and it breaks everything down by proportions in decimal points. And so the first one is the proportions by the rows. So this is 0.27 of non-smokers are in excellent health, and 0.021 of non-smokers are in poor health. When you use the 2, it changes it to rows, or columns, I'm sorry. So the reason this table looks different is this is the percentage of people that are in excellent health who are non-smokers. So here it's the percentage of non-smokers who are in excellent health. So non-smokers, proportions all the way across, and if you added all of this row up, the row would sum to 100. In this case, it's the opposite. It's up and down, so the columns sum to 100. So it's what percentage of this column are in this category non-smoker, and what percentage. So it's 61.8% non-smokers, 38.2% smokers, and it sums to 100. Out in the poor health category, it's 33.8% non-smokers, 66.2% smokers, it sums to 100. So now we're going to look, the next thing we're going to look at are height and weight. And the first thing we're going to do is create two new data frames. One is going to have just the male respondents, and the second one is going to have just the female subjects. So we're separating out by gender, and we're going to actually create two completely separate data frames so we can look at them separately instead of looking at them together. So ran that code. You see that the arrow here is just creating this data frame named m.cdc is a subset of the CDC data frame where gender equals male. So it created that. And then the same thing here for female. I'll go through these lines one at a time. Okay, so I'm going to go through those lines one at a time. Created the data frame for male. The second one creates the data frame for female. And does anybody have any questions about anything so far? I think hopefully it was fairly straightforward, but I know the thing with the columns and rows could be a little confusing, but I think has everybody got that? Okay. All right. So the next step, we're going to reshape the plot so that we get the two rows aligned in a single column, and then it's so that we can run histograms and have them look right. So So now we're going to look at the first histogram. And what this here did was it made it so it shows the two histograms in a single plot. The normal thing would be for each histogram to be in its own plot. So this is telling R that you want two columns or two rows in a single column. And later, I think we'll get to one where we do 3 or 4 in a single column. So we've got one histogram for the males by weight and another for the females by weight. You can see that the central tendency for weight is higher for males than for females. The distribution isn't normal, but we might say it's sort of normal-ish. Obviously, there's a minimum, so you're not going to go below that, and there really isn't a theoretical maximum, except that at some point you probably die. So as a result, it's skewed, but it's still it's skewed, but you still see sort of a grouping around the central tendency, even though it's got a skew to it. Yes.
What do we do if it? Mine says that the figure margins are too large, and I tried to expand the window and then zoom in to where it was my whole screen, but I still can't see it.
Okay. is it not even producing it, or is
No.
it just making it see?
It says error, figure margins too large,
Um,
which I assume meant that it didn't fit the screen.
yeah, we ran into that before, and just expanding the screen helped. If that's not helping, I'll have to do a little research. So I will do that. Um, and yeah, I will look into that. Give me just a second. I want to make a note so that I remember to do that. Um, if you could, would you post the error in the chat so that I have exactly what it is? It'll just make it a little easier to find the.
I was running into that same error just now, and what I did was I expanded my window where the histogram would show up like leftwise, and also made it taller, like pushed it up into the environment tab, and then reran it, and it showed it. So I expanded the left portion of it and the top of it.
Yeah,
huge.
Yeah, that
makes
makes.
my entire screen.
Yeah, that makes sense. It could be because of the two rows, maybe making it too tall. But there's probably a setting that we can fix that will make it not do that. I had that happen one time, but I didn't have it happen this time, so I don't know. Okay, so for the next plot, we're going to actually change back. This is the same command that we used up here to make it 2 rows and 1 column. Now we're going back to a single row, single column. And then we will run these plots. I guess I will. Yeah, I'll run them both, and then we'll look at them individually. So the jitter command that you see here, the reason for that is it makes it adds just a little bit of, just what it sounds like, a little bit of jitter to each plot point in order to make it big enough that you can see. So this is just plotting height versus weight for males, and then height versus weight for females. And this is something we really don't care about as political scientists, but it's a good demonstration because the data is available on the web, and it's some real data that we can work with, and we can do these things to see how to visualize the data. So the next thing we're going to do, you can see one of the points of this is just to see, there's a relationship. I'd say it's probably not linear, but still you probably could plot a line through that. And certainly there's a correlation. I mean, it just makes sense. You're taller, you're going to probably weigh more if everything else is equal. So for the next line is to create a new variable. So you can tell we're creating a new variable. This is calling the data frame, the f.cdc, and creating a new variable called BMI. And we're assigning the value with that arrow. And to assign the value, we have a formula that creates that variable. So we'll do that. And then I'm going to go over real quick and just click on that and make sure that it created it. And sure enough, it did. You can see that it's created all those BMI variables. You could do the same thing for the male data frame if you wanted to. You could also do the same thing for the overall CDC data frame if you wanted to. And if we'd have created it for the CDC data frame to start with, then when we created these data frames, you know, it would have already been in there. So, so now we're going to create a histogram, and we're still in that world where it's going to be one plot, one column, one row, because we haven't changed that back, which is okay. We're only doing one histogram. And so this is showing us the frequency distribution of the different BMIs. Central tendency looks like it is somewhere around 20, 25, 20, a little below 25. And it's grouped around that central tendency, and it has a right skew. The tail extends out to the right more so than the mass. Excuse me. And so the next thing that we're going to do is a box plot. And so this is a box plot of health by BMI for females. And
Excuse me, Tom?
yes,
I'm not seeing that command on my end.
I also don't have the line of code for that.
for the box plot.
Yes.
Yes. And in 33, there's a bunch of coding together.
Okay.
I just typed it in.
Yeah. You can copy it over. The next thing that you should see is this, where it's going to create this. Let's see. Okay. So yeah, you can just copy that over or type it in. And I will tell you that the line numbers on the worksheet will not match the line numbers in the actual R script because there were some spacing issues. So in the next step is creating some new categories based on the BMI. So it's creating these 4 categories: obese, overweight, regular, and underweight. And then we're going to so we're categorizing them, and then the next 2 lines are in order to add those categories into the data frame, and it adds them in as, you know, words: regular, overweight, underweight, and it also adds them in, okay, and obese, and it adds them in also as numbers so that we can use the numbers, because there are a lot of, obviously there are a lot of things that you can't just plug a word into. In fact, most of the things. So,
Excuse me, Tom.
yeah.
I was just starting to get errors for everything after the underweight, regular, overweight, and obese. So the f.cdc, it won't even generate. It just starts telling me errors, everything after that.
Okay. Okay. What sort of errors?
It's looking like it says error, data frame, replacement has 0 rows, data has 10,431. Do you want me to send you those errors?
Yeah. You might. Did you do the git poll that I did at the start of this?
No, for some reason it didn't actually come out in my environment.
Ah, okay. Okay, because I did make some corrections. I didn't think I made any corrections to this particular one, but I did make some corrections when I got some errors in some of the labs as I was going through the scripts. So it's possible that that may be corrected if you get the updated script. But I will look real quick at. Pause the screen sharing so that I can try to get Zoom to let me look at the chat. Well, it does not want to do so. Okay, well, I will, I'm going to go ahead and resume, and I will look at your errors and see what I can find.
No problem, thank you.
Okay. Okay, so the point of these lines was to create the 4 categories, which we did out here, and then these 2 lines add the categories into the f.cdc data frame, and then the levels line is the line that creates the BMI class that's numeric out of the it creates the numeric BMI class out of the factor variable, the variable with just words. So that's something you're going to end up doing a lot. You may find that you have categorical variables where you have maybe some survey data that says, you know, likely, very likely, unlikely, very unlikely, or neutral. And so it's got 5 levels. And so you're going to turn those 5 phrases into 5 factors, 5 numeric factors. And this command, which you'll is what's going to do that for you. And basically the order is under, regular, over, obese. And so you get over is 3 because it was the 3rd one, regular was, you know, the 2nd one, so it's 2, and under, if I can find one, yeah, under should be 1. So it's 1, 2, 3, 4. It just turns these into 1, 2, 3, 4. And the whole point of that was to be able to do this, which is to go back and show that contingency table. And it creates, I started to think it wasn't working right, but it did. We created a table named contingency, and that's what this command does. And so now we can go and do all the things that we did with the other table earlier. In this case, we create a we end up with a contingency table that is, and this is by column. So the column should add to 100. Of the people who were underweight, 25% were in excellent health, 27% were in very good health, 31% in good health, 12% in poor health or in fair health, and 5% in poor health. If we come out to the obese category, only 0.09%, well actually 0.10% were in excellent health, 28% were in very good health, 35% were in good health, 19% were in poor health or in fair health, and 7% were in poor health. So, and then if we wanted to look at that in a more visual sense, we can look at it as bar plots. So this one is the first one, and it's not very, very interpretable. I mean, it is, but I like this one better. It may be your personal preference, but in this one, you can see the different categories, how many fall in each of the health categories. And you can do a legend. This didn't do a legend, but you could do a legend so that you could see. But we know that we already know these are 1, 2, 3, 4. So, sorry, these are the 1, 2, 3, 4. These are the health categories, and they're 1, 2, 3, 4, 5. So we know that this is excellent, very good, good, fair, and poor for each of the weight categories. And you could do something similar with, you could do something similar with survey data if you had, how likely are you to support this initiative? And then your other category might be, are you Democrat, Republican, Independent, or other? And so you'd have 4 categories of voters, and you survey them on a subject. So now we're going to run a different plot, and we're going back to that world where we have a different number, and this is the one where we're going to have 2 columns and 2 rows. So we're going to have 4 plots in the plots over here. And so if you were getting that margins error, you may get that margins error here as well. This is going to create some pie charts. And so it creates a pie chart for each of the weights. And the pie charts are kind of, they're kind of useful for looking at the individual categories. When it plots them all together, it's not as comparable as you would think, because instead of, if I were designing this, I would probably have it so that they all start excellent at midnight, so they're all comparable. But you can see that it doesn't. For regular weight, it starts about 11 o'clock, starts about 1:30 or 2 for overweight, and excellent starts over here for obese, all the way over at 2:30. So it's you can't immediately look at them and say, oh, these line up, because they don't. But still, if you're careful about that, you can use the pie charts. Pie charts aren't used a whole lot in academic writing and political science, but they are useful, if you're giving a presentation, especially to, I don't know that they're even used that much in conference presentations, but if you were giving a presentation to someone who was not a political scientist and you wanted to break something down, pie charts are, something that people are familiar with. So it's useful to know. So we're going to remove everything here and start over. So remember what I said earlier, you need to reset that working directory, because when you erase everything, it erases your working directory too. So down here, after this RM list command, post your working directory back in there again. So you go ahead and do that. I'm I'm going to go ahead and clear these out. You may want to save them. For those of you that were getting errors, when you turn in your lab, go ahead and turn it in and just copy your errors in what you turn in. That way, if I haven't gotten back to you about what I found out about the errors, I'll have that available. I can help you out, and you'll get credit for having done, what you can do. So.
Okay, yeah, because basically after that error, everything else, I just couldn't follow along. It just gave me error for every other command I tried to push through.
Okay. Yeah, well, once you do this, and your line numbers are probably not going to line up exactly with mine because I added some space, but after you run this line where we clear everything out and then you set your working directory again, hopefully things will start working better. So, do that, and then I'm going to run through the first step, or the first example of this is some data from the Houston School District on expulsion rates from a story in the Houston Chronicle, and it says a recent story. I think this story was sometime around 2013 or 2014. So we're going to run through the data with the Houston ISD, and then you'll go through and do the data with the Cypress Fairbanks ISD data on your own. So this is the data. And what we're going to do is enter the data into R, and so these lines, let's see, these lines enter the data for HISD. And if you follow along, you can see so this is each of the categories, the suspensions data for each of the categories, and it's by race, okay? And then these are the enrollment numbers, and they're also by race in the same categories. And the important thing is that they have to go in the same order. So, 39 has to match up with 483. 114 has to match up with 7394. And when you get all the way out to the end, 904 has to match up with 17372. And if all of that is done correctly, then you can do a bar plot. And the bar plot is going to, we didn't actually create a variable name with the race name, but we can add it in the legend because everything went in the order that it is in the chart. And you'll get a bar plot that shows basically proportions. The formula is here, suspensions divided by enrollments. So these are proportions by race of suspensions. So now we're going to create a new table. That we did add in row names here and column names. So we've got suspended or not suspended, and we've got the race names, and then we have the data that was already added in, which is the suspended and not suspended. And so now we're going to do this table that shows suspended versus not suspended for the total. And the reason that we're doing this is because if we want to do a chi-square, we have to know what the totals are for the total table. And this explains how that's computed if you want to compute it by hand. But R will do it for us. And so we see that the chi-square table shows us that there is a significant difference, a p-value of, this is a scientific notation, 2.2 e to the minus 16th, so a very small number. So the p-value is definitely lower than 0.05. So it is significant. So we do reject the null hypothesis. So the next part of the script you're going to do, and the script actually should put the numbers in for you. So these are the suspended and enrolled for Cypress Fairbanks. You're actually going to want to clear the environment. I suppose I guess you don't really need to clear the environment, but it might help. I'll leave that up to you. But starting from here, you're going to recreate everything for the Cypress Fairbanks School District and see how that goes. We don't actually have that much time left in class, but we've got about 12 minutes, and it's not, if you're not having errors, I think you probably actually can get this most of the way done in that time. So I'm going to put you in breakout rooms. I'm going to stop sharing, and I'm going to